Okay, in this video we're going to be doing Calc AB Problem Set 113. The problems and playlists are in the description below. Let's see what we're doing. Find dy dx for 8y cubed plus 7 equals y times sine of x. So implicit differentiation. I like to start off with just showing d dx of both sides so that I'm really focused on what I'm doing. I also forget that step a lot, so I don't think you lose a point for doing that, but you should definitely have this step. So d dx 8y cubed plus 7 is equal to d dx of y times sine of x. On the left-hand side, we're just going to take the derivative with a power rule, but don't forget the chain rule. So 24y squared dy dx, derivative of 7 is 0. On the right-hand side, we have to use the product rule. So it'll be first, derivative of the second is cosine of x, plus second, which is sine of x. Derivative of the first is dy dx. And now we need to solve for dy dx, which means bring everything with the dy dx to one side. I'm going to bring it all to the left-hand side, and then everything, y times cosine of x is the only thing that doesn't have a dy dx, so that's just going to stay where it is. So my final answer is going to end up dy dx is y times cosine of x, and then divided by 24y squared minus sine of x. And that's how I would leave it. It's also possible to write this answer as negative y cosine of x over sine of x minus 24y squared. Just be aware that happens. It happens a lot on implicit, where depending on which way you decide to move things to the left or the right, the positives and negatives can swap themselves. All right, next up, calculator question. Given that f of x is 3 plus cosine of 2x and g of x is 8 minus sine of 5x, is the vertical distance between f of x and g of x increasing or decreasing at x equals 1? So part of the reason that this question exists is that on the AP exam in particular, they ask about vertical distance between two curves kind of frequently. Not like every year, but like it comes up enough that you got to really think about it. So the vertical distance is just, it's just kind of the absolute value of of f of x minus g of x would be the distance between them. In this case, you know that g of x, because it's a sinusoid where you're at 8 and you can go plus or minus 1, versus f of x where you're at 3 and you can go plus or minus 1. G of x is definitely above f of x. So I'm going to say that my v of x function for vertical distance is g of x minus f of x. If you're not sure, you can put the absolute value there, which would definitely tell you the vertical distance, and is probably therefore safer. This is a calculator question, so I'm going to use a calculator to find the derivative of this thing at 1. So I've defined f of x, g of x, and v of x, and then the derivative of v of x at x equals 1 is 0.400. So I'll write down that v of 1 is approximately 0.400. Since v prime of 1 is positive, the distance should be increasing, so let's write that down. Vertical distance is v of x equals g of x minus f of x. V prime of 1 greater than 0, therefore vertical distance is increasing at x equals 1. Good problem. Let's look at the next one. Evaluate the integral from a to b of f of x dx, where a and b are the x coordinates of the relative maximum and minimum, respectively, of f of x equals x cubed minus 3x squared minus 9x plus 2. Okay, so the fact that they are the x coordinates of the relative max and min respectively means a goes with the maximum and b goes with the minimum. We need to figure out where there's a max and a min, which means we need a first derivative. So f prime is 3x squared minus 6x minus 9. We're going to need to factor this thing. Obviously, you can take a 3 out. I don't know why I'm making you watch me write that, but I am. I'm committed. Okay, and then we need to factor it. You don't have to watch that. 3, quantity x minus 3, quantity x plus 1. Do a sign chart for this thing. So it's a quadratic. The f prime is a quadratic that opens up, which means that you're going to go positive, then negative, then positive. So let's fill those in. Or you test the regions, whatever you're comfortable with. So at -1, f prime is going positive to negative. That's our relative max. At 3, we're going negative to positive on f prime, so relative min. All right, so now we got to actually do the integral. So we're going -1 to 3 because we had to go from max to min. X cubed, so the function. Let's reverse the power rule. 1/4 x to the 4th minus x cubed minus 9/2 x squared plus 2x. We have to evaluate it from -1 to 3. All right, so when you plug in, plugging in 3, we're going to get 81 over 4 minus 27 minus 81 over 2 plus 6. Then we're going to plug in, minus plug in -1, and we get 1/4 plus 1 minus 9/2 minus 2. Okay, so here's something I would encourage you to do. Don't try to simplify each of these sets of parentheses individually, because what happens, because you're plugging into like 1/4 x to the 4th twice, kind of pair those things up, and usually the simplification is faster. So I'm going to look at these two things, and I'm going to say that's definitely just 80/4, so 20. And then I'm going to keep going with that, right? Here, that's -28. And then we're going to pair up these, which is -90/2, so -40, so -90. Am I doing that wrong? Oh, no, it's not. It's -72/2. It's like I am doing that wrong. And then 6 plus 2 is 8. So if you pair them up, it's a little easier than trying to like simplify the first thing, simplify the second thing, and then combine them. Highly recommend that. It's just one of those little things that'll save you a lot of time. All right, new problem. Evaluate. The limit as n approaches infinity of this weird thing. This is definitely a definite integral. So we're going to change this into a definite integral. It's a limit of a Riemann sum. On the AP exam, they're almost 100% right Riemann sums. I actually think they are 100% right Riemann sums. I can't think of a time there was a left Riemann sum for this process. But, I mean, there's no rule that says it couldn't be. Anyway, we need to figure out what delta x is, but it's just sitting there, right? Now what we need to do, so we know delta x is 1/n. We have to like work out what else is going on. So if I look at this, I think this looks like 1 plus 3 times 1/n. I think this looks like 1 plus 3 times 2/n. And then in general, this looks like 1 plus, so I'm looking at just the denominators, obviously, 1 plus 3 times n/n. So I think that x sub I is going to just be I times delta x, or I/n. And then I think my function is going to be 1/1 plus 3x, and that's what I'm plugging into. So I have to figure out where to start and where to stop. So that's x sub 0, which is 0. You're plugging in for I. I is equal to 0, so you get 0/n, which is 0. Plug in n, you get n/n, which is 1. I've said I think that f of x is 1/1 plus 3x. There's multiple interpretations of this, so you might write a different definite integral. As long as by u substitution they end up the same integral, we're going to be fine. So here's our integral. We're going from 0 to 1, 1/1 plus 3x dx. All right, so there should be a 3 in the numerator by the chain rule. So that would put a 1/3 on the outside. And now we made it perfect on the inside. So this will be 1/3 natural log absolute value 1 plus 3x. And we're going from 0 to 1. So 1/3. When you plug in 1, you get 4. When you plug in 0, you get natural log of 1. But the natural log of 1 is 0, so you don't have to worry about that. And so we get 1/3 the natural log of 4. That's it for the problem set. I hope this was helpful, and good luck.